starting with a sphere because hot air balloons are basically spherical, and I'm going to add a cylinder to the bottom of it, and something like this, and I'm going to move it in the y direction by minus 100. And by adding a rounding factor to this, can smoothly union it, so the shapes kind of merge together. So I think 50 looks good. And hot air balloons aren't perfectly spherical. They're close, but their tops are kind of squished. So I'm going to scale it in the y direction, and I can just do this and squish it, but they don't look like that. They're not symmetrically squished. So I'm going to scale it by a factor that depends on the y-axis. And so the bottom of this is minus 100 for the radius of the sphere and minus 50 for the height of the cylinder. And I'm going to scale it along y from the bottom to the top. And I'm going to scale it at the bottom. I want it to be 1, so no difference. And at the top, I want it to be squished. Okay, so that's a little bit too squished. But as I play with this number, you can see how it's squishing it towards the origin, which is the center of the sphere, by a factor that depends on the height. So I think 80 looks pretty good. And we have a water tower, and it's not a water tower is not quite a hot air balloon, but it's close. So to add the folds, the ridges around the hot air balloon, we're going to use the radial operation, and I'm just going to show you how it works first. Radial takes a count, and then it takes optionally it takes a radius that'll outset your shape by, and this is very, very cheap. Even though we're kind of duplicating the shape, we're only evaluating one sphere at a time as we ray march. We sort of slice space into a pie with 12 slices, and we only are ever looking at the sphere in the current slice. So it's just doing this division basically modulo the angle trick to only evaluate a small subset of it, which only really works if your shape is symmetric. So as we make it like not symmetric, you can see these bizarre artifacts creep in, and our ray marcher is overshooting and landing inside of these spheres because it's not actually giving me a valid distance field. But this is symmetric, so we don't need to worry about that. We can take radial around the y-axis, say 12, and we can't see because our shape is already radially symmetric unless we outset it, but that's obviously not what we want. So we're going to make our shape not be radially symmetric by scaling it in the z direction, 0.5. And we could make that more or less to make it pointier or less pointy, but 0.5 looks good. I think probably 18 is a good, yeah, so that looks good. But I don't like it here at the bottom. And Bobble doesn't have any way to change. The camera always rotates around the origin. So to show you the bottom, I'm going to move the whole shape up. So the bottom is now at the origin. Cool. So it shouldn't be quite as ridged down here. I want this to attenuate as it gets towards the bottom. I want it to be flatter. And to make it flatter, I have to make this shape flatter by an amount that varies both on y and x. So what I'm going to do is scale. The radius of the cylinder is 25, so I'm going to give this a pivot at 25 and scale in the x direction, right? Okay, so you can see that I'm scaling, I'm sort of pinching space towards that corner, but I don't want to pinch space, I only want to pinch towards the bottom. So I'll do another smooth step of p.y from bottom to maybe 10 bottom and 0.5 to 1 probably. Okay, so I pinch space towards this corner, but I want to not pinch space in the x direction. So what I'm going to do is say, instead of from 0.5 to 1, I'm going to use this as another parameter. So I'll say that 1 is fully pinched and 0 is not pinched at all. And I'll pass this to a mix. So 1 is fully pinched, 0 is not pinched at all. So I'll use this to mix the value. Okay. Using the value of the smooth step, and I'm doing that so that I can combine this with another smooth step by multiplying it. So multiply the x I want to take the distance to the bottom from 1 to 0. So 0 is fully pinched, 10 is not pinched at all. So I multiplied these two. Oh, I think they don't multiply right the way that I did it. I think I have to invert this maybe. The absolute value of p dot x from 0 to 10, or no, I had it right, I just had the wrong number of arguments. Okay, so I'm pinching space by a factor you can see here that kind of falls off as it gets farther from the x-axis. I feel like that looks pretty good. Yeah. Okay, so that's now quite flat over there. So how's that look when I take the radial? Pretty good. Ignore the artifacts. We're just getting space is hard to ray march through in this space because of the stretching kind of affects the distance field in weird ways, but it looks pretty good when you're not right up next to it. So let's make that a little bit higher. Yeah. Okay, I think that looks good. Let's move it back down. So now we can move this by kind of not quite all the way. Okay, makes it feel more centered. So let's talk about surfacing it. So a shape in Bobble is a pair of two things. It's a distance field and it's a color field. And both of these are just functions that take a point. The distance field, you evaluate the field at a certain point and it gives you a value, which is the nearest distance, the distance to the nearest shape. The color field just gives you a color. So I'm going to go back to a sphere and I'm going to color it. And you can see, I can pass it yellow, whatever. I'm going to use HSV because that'll make it easier to pick these colors. And I'm going to use P.Y, fully saturated and fully bright. So the hue is P.Y, but I don't really want that. I want it to be divided by 100. Good. And I want to quantize this. So I want it to be striped. I don't want it to be the smooth gradient. So times 8, and then round it, and then divide it by 8. Yep. So I just quantized this. This feels like should probably be a helper. X times y round divided by y. So I can, these scroll bars are really throwing me off. Quantize 8. Okay, or 10, or whatever, 4, 5, 7. 8 looks pretty good. Okay. So this is a shape with a color field. I don't have to apply it though. I can just call color to just get the color field. And I'm going to give this a name. I'm going to call it chevrons, and you'll see why in a second. So let's take a look at chevrons, and we can apply this to different shapes. So like a sphere, can apply chevrons, and chevrons doesn't actually look like chevrons yet. So I'm going to take this and I'm going to rotate the whole thing. I'm going to rotate the color field. And then when I apply this to something, sphere was a terrible example, but I'm going to apply this to this box. You can see just the color field has been rotated. I didn't rotate the box at all. And that's a really weird factor to rotate by. So we're going to use this to apply this to our hot air balloon. And I'm going to do that. So we can do that. We can apply this to the whole hot air balloon. Resurface with chevrons. That's not actually one. Also, I'm using color here, which just gives me a flat color, but I'm going to use shade, whose first argument is a color, and this gives me a blend fong shader. So there's no way to control the lighting in Bobble right now, which is really annoying. So we kind of have these dim, terrible lights, but we can get a better sense of the shape, whereas color kind of blows out all of the definition. Okay, so we have this shaded thing, but I don't actually want to apply it to the whole hot air balloon. I want to apply it to a single one of the hot air balloon's lobes. And you can't really, that's not quite, I'm rotating it around the wrong axis. There you go. So these are not chevrons, you'll notice. So in order to make them chevrons, what I'm going to do is pass a function to radial, and this is going to map the lobe as it rotates around, as it copies it, it's going to map it as well by the function that I pass in. So what I'm going to do, I is an index, so it'll be 0 to 17 for which lobe I'm shading at the moment, or creating at the moment. So I'm going to flip every other one. So mod I2 will give me every other one, and that's 0 or 1. I'm going to multiply by 2 and subtract 1 to get -1 or 1, and use that to scale in the z direction, I think. Yeah. Cool. And then I can rotate this to get more kind of severe chevrons, or I can change the phase a little bit to, if I want kind of red at the dominant color. Cool. So that's a pretty good hot air balloon. It's not hollow though, which is a mistake. So I'm gonna go back to shaping it out here, and I'm going to before I do anything else, subtract a half space, -y at the bottom. So this is kind of cool. I'm gonna add plus bottom 5, I don't know. So as this varies, you can see I'm kind of taking a cross section of the hot air balloon, which is cool, but it's not what I want. So the hot air balloon is solid right now, and it shouldn't be. So I'm gonna use the onion operator to give it, to make it hollow with a certain thickness. And then as I take the cross section, it's like a little bit more logically a hot air balloon. 1 is way too thick, I think like 0.1. And let's look at it from the bottom. It looks pretty good. Okay, so now I have a hollow hot air balloon, which is much better. And what next? So we only have one hot air balloon. It would be cool if we had more than one hot air balloon. So we can tile this in space. So tile, just like radial, we're gonna give it an offset, and it's going to very cheaply, 300? It's going to very cheaply copy it because it's only ever looking at the nearest hot air balloon. So that's pretty good. But we can do this in more than one dimensions, and it's weird, and that's not kind of terrifying. Okay, I'm just gonna do it in, yeah, sure, I'll do it back there too. So we have an infinite number of hot air balloons now, but they're all the same hot air balloon, and that's boring. So instead of this version of tile, where I'm using tile on an existing shape, I'm gonna use tile to create a shape. And this will allow me to create a different shape every time. So it's gonna give me an index just like radial did, but it's gonna be a vector of 3 components for the x, y, and z tiling. I'm gonna call it j, and then I'm gonna return our sphere from this tile generating function. So far everything exactly the same, not a big deal. And then actually, so that we can do more interesting things, I'm gonna take chevrons and going to move it in here. Is this? So resurface the shape, take that out of there, and resurface the shape in here with the value of the chevrons. And then take that and scale it. And what is my error? Shape specified multiple times because I have the scale down here. Okay. Okay, so far everything is identical. But now I have access to j, and I can do things with it. So what do we want to do with it? Take j.x and multiply it by some number that is, I don't know, 13. So now we have a slightly different phase based on the x the x component of the tile index. And that's already kind of a cool effect, but we could take the sum of j, and then I'll add the X, Y, and Z components all together, and the Y component is 0 because it's not tiling in the Y direction, but it could be if we wanted it to, and this gets pretty wacky, but nope. So here we have a different pattern now, which is neat. So let's take another thing and let's rotate. Let's change this as well. I'm just going to use the same index as the sum. You can see there, since I'm just using the sum, it's not really random. We still get these stripes along the diagonal, but if you look like this, then I don't know. Ignore that maybe. Actually, let's not ignore that. Let's take this and multiply it by, I don't know, some like weird numbers, pi, and then take the sum of it. Does that work at all? No, because this is actually 3, but it doesn't matter. Okay, so that makes it much harder to see the patterns. This is still symmetrical, but so maybe j times, I don't know, 99 point something. Oh, up here it doesn't actually matter as long as it's that. Okay, so now we're getting like more random-ish, maybe numbers. I don't know. There's like hashing functions that you can apply by taking a really high frequency sine wave and you get kind of pseudo-random numbers in GLSL. But I'm not gonna write that correctly while doing this recording. So here we have an infinite number. So another thing that we could do with the chevrons is we could, in addition to rotating, why don't we also move this by a value that depends on I, so times 10I maybe. That's kind of cool. It's kind of a cool effect. You see that in hot air balloons sometimes where you get this like striation. But let's give it, let's have the amount. I really just want to like take a random number. So the sum of j, or let's dot j with some, this is how you were like supposed to do it, some wacky number, and then we'll multiply it by something very large. It's not very large, and take the sign of it. And my font is so big that I can't see what I'm doing anymore. Take the sign of it, don't call it. So this value here is a random number. I'm going to multiply it by 10 and multiply that by I, and then close that. And that's a 3-component vector, even though, okay. So now I have kind of, you can see that since j is 0, this is just 0, we're getting nothing, but now it's kind of a randomized amount of offset. So these are not really as good. I don't know, I might just take off the move altogether so that we have kind of more symmetrical hot air balloons. If you found like exactly the right one, but whatever. So that is an infinite number of procedurally generated hot air balloons in Babel.